Hello learners, this is education online program. With you is teacher Rose. I'm hereby to present for you a lesson in chemistry for senior 1 and 2. And our topic for today is about separation of mixtures. In separation of mixtures, we will be specific at fractional distillation. Fractional distillation is the process of fractional distillation is the process of separating two or more liquids. Of course, when we have a mixture of miscible liquid, that is when the liquid mix, the mixture is the same at all proportion. That is total mixing of, you cannot differentiate between one liquid from the other. Like we have alcohol and water. So these are miscible liquids. So fractional distillation is the process of separating two or more liquids. And mostly fractional distillation is applied to miscible liquids. And for our lesson for today, we are going to be specific. We are going to focus at fractional distillation of Groot oil. Fractional distillation of Groot oil. Sometimes we call it petrol. So Groot oil is a black liquid that has got a very strong smell. And Groot oil is mostly, or is generally, it is made up of a mixture of different hydrocarbons. Groot oil is made up of a mixture of different hydrocarbons. And these different hydrocarbons are called fractions. They are called fractions. Fractions of Groot oil. And by hydrocarbons, we mean compounds of carbon and hydrogen. That is compounds of hydrogen and carbon. That is compounds that are basically formed from combination of hydrogen and carbon. And then in the process of fractional distillation, the fractions or the different hydrocarbons that is in the mixture. Of course, we say that Groot oil is a mixture of different hydrocarbons, and these different hydrocarbons are called fractions. So these fractions sometimes, or during fractional distillation, is called distillate. So the distillate here will be the different substances that is in the mixture. And then Groot oil, when it is not separated, it is not useful. Usually Groot oil is useful when it is separated into different mixtures. And then this fractional distillation takes place with the help of what is called fractionating column. Fractionating column. And this fractional distillation is based on the principle of different boiling points and condensation temperatures. So what we have is, within the mixture, the different hydrocarbons that, or the different components of the mixture, has got different boiling points. And then they condense at different temperatures. That's why we will boil the Groot oil, or we heat the Groot oil at different temperatures. Then we get different components, that is different fractions of hydrocarbon. So as I said, the principle is based on different boiling points, and then also they condense at different temperatures. Therefore, each fraction of the mixture will boil at a different temperature, and then it will be condensed at a different temperature, so that at last we get different substances. So let us look at a sketch of the fractionating column, how the fractionating column looks like. The petrol or the Groot oil will be first placed in a furnace. It will be heated in a furnace. So, for example, let us assume that this is our furnace. In the furnace there is a pipe, an outlet pipe and an inlet pipe. So this one comes and then we have, this is the fractionating column looks like this. This is our fractionating column with various ends that has got also different temperature levels. Okay. Then at the bottom here we have what is called the residue. The residue can be in form of asphalt. Then at the bottom we have the temperature degrees is 400 degrees Celsius. The next is 370 degrees Celsius. Then we have 300 degrees Celsius. Then we have 200 degrees Celsius. At the top we have like 150 degrees Celsius. So we have evaporation of a gas at the top, and then the gas that evaporates at the top and then at temperature 200 we have gasoline. Then at this temperature range we have kerosene. We have diesel. And then we have our fuel. So this is where the Groot oil will be injected. This is a sketch of a fractionating column. We have, this is the furnace where heat is applied. Then the Groot oil will pass from here, heated, then it will pass through the fractionating column. Then we have mixtures that have got a large number of hydrocarbons or have got large number of carbon compounds. They will be at the bottom because they need high boiling point. And then the mixtures that has got a small number of carbon atoms will be at the top because they need low boiling point. That is to say, substances in the process of heating in the fractionating column, what happened is we have the intermolecular forces of attraction will be broken down. Intermolecular forces of attraction between the molecules will be broken down to separate the molecules, but the chemical bonds remains. The chemical bonds will not be touched. Then that is to say that this is an implication that the chemical properties of the fractions will not change because we don't change the structure. We don't change the structure. And then the bigger molecules with large number of carbon, they need high boiling point, and they will be at the lower side, the lower end of the fractionating column, because they have got high intermolecular forces of attraction, and they will need high energy to break down those intermolecular forces. That is to say, the most volatile, that is the lighter fraction. The lighter fraction will evaporate fast, but that is the volatile, the most volatile. The less volatile, that is the molecule that have got that is big, that has got large number of carbon atoms, will be at the bottom because they need high energy to break down the intermolecular forces of attraction. That's why we have fuel, followed by diesel, kerosene, gasoline, and then we have the gas. The gas is very light. Then, following this separation, we look at the nature of these fractions. Like for example, we have the gas, that is refinery gas at temperature at around 150 up to 20. We have the fuel gas. This gas has got at least 1 to 4, that is number of carbon atoms, so it is very light. And then the boiling point is between 160 to 20 degrees Celsius. And the gas that we have here is like methane gas. Methane gas is having 1 to 4 carbon atoms. This is an organic gas. Looks like the structure is skeleton is like that. So we use methane gas. This is the potable gas that we have. It's potable. Can be filled in cylinders, and mostly people use it for cooking. Then we have gasoline. This one have got at least 5 to 11 carbon atoms. And then it boils at around 20 to 60 degrees Celsius. It is highly flammable. It can evaporate easily, and then it is easily ignited also. Can catch fire easily. Then we have what is called naphtha. Naphtha has 7 to 13 number of carbon atoms. The boiling range is 60 degrees Celsius to 180. And then it is not good as fuel. It is valuable source of organic molecule to make more petrol. It is valuable to make petrol. Then we have kerosene or paraffin. This one is the number of carbon atoms ranges between 10 to 16. The temperature range is between 220 to 250 degrees Celsius. It is not easily evaporated. And then also it is less flammable. It is less flammable than petrol. It's less flammable. And then at homes we use it for domestic heater, and then it is mostly used as jet fuel for flying planes. It's used as jet fuel. Then we have diesel. It is a bit heavy. We have diesel oil or gas oil. it has got 20 to 70 carbon atoms. The temperature range is 250 to 350 degrees Celsius. And then this diesel is used for large vehicle. It is used as fuel. It is used as fuel for large vehicles. Then we have fuel and lubricating oils. We have fuel and lubricating oils, or sometimes they are called lubricants. This one here has got over 70 carbon atoms, and the temperature range is over 350 degrees Celsius. And then it forms a thick black tuff. It is resistant, adhesive on cooling. It is used sometimes as a waterproof material for waterproofing. And then it used as to stick or clips on roofs and then on road surfaces. So when we look at this table, these are the various components of Groot Oil. We have the gas, gasoline, naphtha, paraffin or kerosene, diesel, and then the lubricants. So all these will be obtained in the fractionating column, and in this fractionating column there is what is called trays. When they evaporate and then they are condensed, they will be collected in these trays. So in these trays we will have various fractions. And these fractions could be gas or gasoline, naphtha, paraffin, diesel oil, and then fuel. And as I have stated that Groot Oil, if it is Groot Oil in nature, it is not useful, but it is useful when it is separated into different forms. And I said this process of fractional distillation is based on the principle of different boiling point and then condensation temperatures. So when we look at this fractionating column, we have the first level of temperature is 400 degrees. Here we have the fuel. And when we look at the fuel, we say that because it is the molecule is very large, that is why the intermolecular forces of attraction is very strong, and then we need large energy in order to break the intermolecular forces of attraction. So heavy molecules are always at the bottom, and then light molecules are at the top because they evaporate faster and then they condense fast. Therefore, as I said, fractional distillation is used for separation of miscible liquids. So when you look at Groot Oil physically, you cannot see these different components unless we apply fractional distillation to the Groot Oil. Then we can get the different fractions, and of course based on this table, these different fractions each has got a different function. So fractional distillation is used for separation of miscible liquid on the principle of different boiling point and then condensation temperatures. And then what happened is breaking of the intermolecular forces of attraction between the molecules. So the chemical substance of the fraction doesn't change. What changes it doesn't change because the chemical bonds remain, and then the nature of the molecules are retained. That's why we say that we only separate but we don't change the nature. So dear learners, we have come to the end of our lesson for today. Bye bye, see you in the next lesson.